So let's start with the problem. So let me first create a table. So let me create name of hardness causing substance this is one, and the other is the amount of hardness causing salts. So amount of hardness causing salts, right? And then the molecular weight and amount equivalent to CaCO3, equivalent to CaCO3, right? So now let's calculate the temporary hardness. Now let's fill up this table. So we have MgHCO32 as we have MgHCO32. The amount is 73, and this is in milligram per liter, and this is also in milligram per liter. This is 73 milligram per liter, and the molecular weight for this is 146. And so the multiplication factor would be 73 into, and multiplication factor would be 100 by 146. So 2, this is equal to 50. Next is CaCl2. Amount given is 111 milligrams per liter, and the molecular weight is also 111. So multiplication factor would be 100 by 111. So this would be 100. Okay. Next given is CaHCO32. So the amount of hardness causing salts for this is 81, and the molecular weight for this is 162. So 81 into 100 by 162, which is the multiplication factor, and so we get 50 in terms of CaCO3 equivalent. Next one is MgSO4. Amount given is 40 milligram per liter, and the molecular weight is 120. And so the amount equivalent to CaCO3 is 40 into the multiplication factor, which is 100 by 120. So this is equal to 33.33. Again, now MgCl2. Amount given is 95, and molecular weight is also 95. So amount equivalent to CaCO3 would be 95 into multiplication factor is 100 by 95. So equivalent to CaCO3 is 100. Right. Now let us calculate temporary hardness. Temporary hardness. So to calculate temporary hardness, we have to identify the salts causing temporary hardness. So in this case, it's MgHCO3, magnesium bicarbonate. So the amount equivalent in CaCO3 equivalent is 50. So we add 50 plus, it's also calcium bicarbonate, and the amount equivalent to CaCO3 is 50. 50 plus 50, and there is no other salt here which causes temporary hardness except these two. So temporary hardness would be equal to 50 plus 50, 100 milligrams per liter. This is the temporary hardness. Let's calculate permanent hardness now. Permanent hardness. Now let's identify the salts causing permanent hardness. So CaCl2 causes permanent hardness, and so the calcium carbonate equivalent is 100. So 100. Again, MgSO4 causes permanent hardness, and the calcium carbonate equivalent is 33.33. And also MgCl2 causes permanent hardness. So this is equal to 100 plus 33 plus 33, 100 plus 33.33 plus 100. So the permanent hardness is 233.33 milligrams per liter. And finally, to calculate total hardness, we just add up temporary hardness and permanent hardness. So 100 plus 233.33. This is equal to 333.33 milligrams per liter. So this is about the first problem. Now let's move on to our second problem. So let's start with our problem number 2. Okay, so as we've seen the problem is a sample of water is found to contain following dissolving salts in milligrams per liter. So let me create the table again. So name of hardness causing substance, name of hardness causing substance, and then amount given. So this is in milligrams per liter. Okay, now again now I'm omitting the molecular weight for this, as we can directly multiply the amount given into the multiplication factor. So I would write equivalent in CaCO3. This is also in milligrams per liter. Okay, so let's start. The first hardness causing substance given is magnesium bicarbonate, and the amount given is 16.8 milligrams per liter. So the multiplication factor we know is 100 by 146. So simply multiply it 16.8 into 100 by 146. So this will give amount equivalent, which is 11.5. Next one is MgCl2, and the amount given is 12. So the multiplication factor we know is 100 by 95. So 12 into 100 by 95. So let me calculate it with the help of a calculator. This comes out to be 12.63. Okay, this comes out to be 12.63. The next one given is MgSO4. So MgSO4, and the amount given is 29.6 milligrams per liter, and the multiplication factor we know is 100 by 120. So 29.6 into 100 by 120. Let me use the calculator again. Yeah, So this comes out to be 24.66. And the other substance given is NaCl. The amount given is 5, but as we know, NaCl does not contribute to hardness in water, so hence it is ignored. So now let's calculate temporary hardness. Temporary hardness would be, first of all, magnesium bicarbonate contributes to temporary hardness, and the amount equivalent is 11.5. So 11.5, and there is no other substance contributing to temporary hardness. So our temporary hardness is 11.5 milligrams per liter. Let's calculate permanent hardness. Permanent hardness. Okay, so magnesium chloride contributes, so it's 12.63 plus. Also MgSO4 contributes to permanent hardness, so 24.66, and there is no other substance contributing to permanent hardness except these two. So our permanent hardness would come out to be 37.29 milligrams per liter. Okay, this comes out to be 37.29 milligrams per liter. Okay, so now let's calculate total hardness for this. Total hardness comes out to be temporary hardness plus permanent hardness. So temporary hardness is 11.5 and permanent hardness is 37.29. So total hardness would come out to be 48.79 milligrams per liter. So these are some numerical problems on hardness, and in the next video we'll discuss further topics. Thank you.